Hi friends, how are you? I think that all of you are very good. Thanks for watching my channel. This is the lecture of qualitative chemistry channel. If anyone has not yet subscribed my channel, please do subscribe as soon as possible. Okay, thank you. Today I will discuss about the configuration of electron in the molecules. You know that there are different rules. There are different rules of scientists for the configuration of the electron in an atom. You know that electron cannot be stay in an atom here and there. There is some rules which has been given by the different scientists. There is a Ohm's rule. Ohm's rule. There is a Ohm's rules. Above principle, Ohm's rule, above principle, Pauli's exclusion. Ohm's rules, above principles, Pauli's exclusion. So I am explaining all of this one by one. In your exam, some atom can be given to you to do configuration of the electron according to the Ohm's rules, according to the above rules, according to the Pauli's exclusion. What is the Pauli's exclusion? There is a question you may have in the exam. On the other hand, to know the chemistry, you have to understand properly electron configuration of the atom. Clear? Okay. Previously, you know that in an atom there is a different shell, n equal to 1, 2, 3. Electron is entered into the different shell according to the high energy level of the shell. That means 4, 3, 2, 1. That means this is the first shell of an atom. First electron will be here, then here, then here, then here. This is the sequence. This is the sequence of high energy level of the shell. Okay. Previously you know that this is the first shell, K, L, N. This is the first shell. First of all, electron will be available here, then this, then this, then this. You know this. Okay, I'm not. You know that there is a subshell. There is a subshell S, P, D, F. There is a subshell SPDF. You know that n equal to 4. N equal to 4 means n equal to 0, 1, 2, 3. That means SPDF subshell. SPDF subshell. So this is the fourth. That means 4S, 4P, 4D, 4F. So when you have the 32 electron, where electron will enter first. This is the level of 4. That means this is the fourth shell. This fourth shell has 4 SPDF subshell. This 4 subshell can be stated. You know the 2n square sutra, 2n square equation, you know, 32. This 32 electron you have to fill in the subshell. First of all, will be here 6, 10, and 14. Okay, clear? That means according to the sequence of energy level of subshell, electron is entered. The entrance of electron is followed according to the energy, according to the high energy level of subshell. First S, then P, then D, then D, F. Okay, clear. This is the clear. When L equal to 3, when L equal to 2, L equal to 0 and 1. That means S and P. Clear? That means 2S, 2P. 2S, 2P. This is the subshell. In the second shell, 2S, 2P subshell. So 2P subshell is oriented to Px, to Py, to Pz. Clear? 2Px, 2Py, 2Pz. 2P subshell is oriented in 3 ways: 2Px, 2Py, 2Pz. According to the Ohm's rule, he told that, you know that P electron maximum can be available 6, P 6, D 10, F 14, S 2. Clear? S 2, P 6, D 10, F 14. That means S subshell electron can be available maximum 2, P maximum 6, D maximum 10, F maximum 14. You have to memorize this. Clear? You have to memorize this. So P is the 6th orbital. P subshell is the 2Px, 2Py, 2Pz. That means 6 electron. So according to the Ohm's rule, first when you have to configure the electron, first 1, 1, 1. Then another 1. Then another 1. Because you know that there is the 4 quantum numbers. There is also the spin quantum numbers in the last one. In a spin quantum numbers, in a subshell, in an orbital, there can be 2 electrons. One electron is clockwise, one electron is anti-clockwise. That means this is the in an orbital in an orbital maximum 2 electron can be occupied. Okay, but that should be two ways. One should be anti-clockwise, another should be clockwise spin. Clear? That means, okay, during the configuration of the electron, when you will have the 5 electron here, then what will you do? You have to give 1, 1, 1. You have the 5 electron. Then another one here. Another one here. This will be the one. That means 2px, 2py, 2pj. Clear? This is the rules of Horns. So from the principle of Horns, what we found, that is every orbital can be occupied by the maximum 2 electrons, but that should be reverse spin. One should be clockwise, another should be anti-clockwise. There is also another important thing, that the energy of px, energy of py, energy of pz are the same. Energy of px, py, pz are the same. Clear? Okay, if you have the 2 electron here, 2 electron here, how will you configure? First you have to give, one is here, one is here, another is here. Clear? If you have the 2 electron in the 2p subshell, if you have the 2 electrons in the 2p subshell, then you have to configure according to the Horn's rule like this way: 2px, 2py, 2pz, 1, 1. Clear? Because you can do, you know that in a orbital we can give 2 electrons. You cannot do like this. You cannot do like this. As you have the 2 electrons, so you have to give 1 by 1. One is here, one is here. As you don't have another electron, so pz orbital should be 0. Clear? pz orbital, there is no electron in the pz orbitals. It is because all px, py, pz are the same energetic, orbitals. That's why all our p orbitals are the same energy. It is okay. If you have the 5 orbital, 5 electron in 2p subshell, how will you do? 2px, 2py, 2pz. You have 5. So how will you configure of the electron in the 2 orbitals? First you have to give here, here, here. Then you have the remaining 2. Then put it here, then put it here. Few minutes ago I described. Then pins 2px, 2py, 2py, 2p. Clear? You have to memorize that in the s orbital maximum 2, p subshell maximum 6, d subshell maximum 10, f subshell maximum 40 electron can be occupied. So from the Ohm's rule, what we learned, when a subshell is oriented at different orbitals, all orbitals has the same energy. So during the electron configuration, according to the Ohm's, you have to fill one by one in every orbitals, and you cannot put more than 2 electrons in any orbitals. Clear? Okay. For example, when n equal to 4, n equal to 0, 1, 2, 3. That means S, P, D, F. Clear? SPDF. SPDF. So SPDF 4D. When n equal to 3, n equal to 0, 1, 2. SPD. That means 3D, 3D, 3S, 3D orbitals. Okay, we discussed about the 3D orbitals. 3D orbitals. This is the 3D subshell. This is the 3D subshell. You know that 3D subshell has how many orbitals? In my previous lecture, I illustrated this. D orbital, this subshell can be made 5 orbital. One is the D XY, D YZ, D ZX, D x square minus y square, D Z square. These 5 orbitals. So you know that in a D subshell, how many electrons can be occupied? 10. So 10 electron you distribute here. One of the very important things that every orbitals can be occupied maximum 2 electron, because one electron is spin according to the clockwise, another electron is spin according to the anti-clockwise. According to the Ohm's rule, this is must. So 10 electron, how can we? There should be the 2 electron, 2, 2, 2, 2. Clear? That means I have already told that this energy level, this energy level, this energy level, this energy level, these energy levels are the same. As you have the 8 electron. 8 electron, how will you distribute here? So first you give give 1, 1, 1, 1, 1, because all have same energy. So 5, then 5, 6, 7, 8. That means 2 square, this 2 Z square, Z square. Clear? This is the configuration of the electron of d orbitals. This is the configuration of the electron in d orbitals. So one of the main things you have to memorize that whatever electrons you have for the distribution in the orbitals, first of all you have to give 1 by 1. Clear? If you have the more, then start giving another 1 by 1. Clear? For example, you have the 6 electron. You have to configure here. So how it is possible? 1, 1, 1. That means there is a 5 electron you have to distribute. You have to distribute all of d orbitals. So 1 by 1, 1, 1, 1. Then you have, but remaining you have the 1. So another 1 you have to give here. That means 2. If you have the 4 electron, how will you do? Then this would be the 0. This would be the 0. As I told that all of are the same energy, so you have to distribute the electron from starting the first 1, 1, 1. But if you don't give it here, if you give it here, it is also possible. But in general sense, you can think that there should be the systematic way. As this is the first orientation, second, third, fourth, fifth, fifth. That's why you have to give it here. You leave 0 here. This is the configuration of the electron according to the Ohm's rule. Clear? I think that you understand very clearly. If you have any problem, please do comments in my channel. Then I will rectify that. Okay? Ohm's rule you understand, I think that very clearly. Ohm's rule for the electron configuration. Okay? There is the Pauli's exclusion. Pauli's exclusion. What is the Pauli's exclusion? Okay, in a definition I can tell you that in an atom 2 electron. For the 2 electron, the value of 4 quantum numbers will not be the same. For the please give the concentration. The definition of the Pauli's exclusion. The definition of the Pauli's exclusion is the value of the 4 quantum numbers are not same. For 2 electron in an atom. So that means helium, you know that helium has the 2 atomic numbers. Its electron configuration is 2s². Okay, electron configuration is 2s². Clear? The value of 4 quantum numbers are not same for the 2 electron in an atom. Okay, let's start to explain what is it. To s². Clear? For the east electron, n equal to 1, n equal to 0. You know, clear? For the east electron, that means for the east electron, n equal to 1, n equal to 0, m equal to 0. But spin quantum numbers is the +12. Clear? second electron in that atom. Second electron, for the second electron, n equal to 1, l equal to 0, m equal to 0, s equal to minus half. Because you know that in an orbital, two electron can be occupied maximum, but that two electron should be to reverse spin. One should be anti-clockwise, another should be clockwise spin, which I told you previously. Clear? That means for the first electron, 2s square. For the first electron, n equal to 1, l equal to 0, m equal to 0, s equal to plus half. Second electron, helium 2. Okay, its electron configuration is a 2s square. Square means 2 electron. So n equal to 1, l equal to 0, m equal to 0. Clear? This is the Pauli's exclusion. So, what have you learned about the Pauli's exclusion? For the two electron in an atom, 4 quantum numbers. The value of 4 quantum numbers are not the same. This is the for example, first electron, nth value is 1. L value is 0, m value is 0. But s, for quantum numbers, s value is the plus half. For the second electron, s value is the minus half. Okay. Now let's start above principles. Above principles, German language. This is the German language. Above principles, this is the building. Okay. Above principles, there is a different subshell. There is a different subshell. S, P, D, F. Different subshell. Different subshell. Electron is entered in different subshell according to the high energy level order. Okay. The entrance of it. The entrance of electron in orbitals. The entrance of electrons in orbital is maintained according to the sequence of high energy level. That means F, D, P, like this. Okay. Clear? The entrance of electron in the orbitals is maintained according to the sequence of high energy level. High energy level. Okay. It will be very clear after a few minutes. For example, 3D. and 3 4s. You have the electron, for example, you have the 5 electron. You have to configure. Will it be here or here? How? You know that 3D means what? 3 means third shell. That means first quantum number 3. N equal to 3. Clear? N equal to 3. N equal to 3. D means L equal to 2. Because you know that L equal to 0, 1, 2, 3. L equal S, P, D. Clear? 3D means 3 means N equal to 3, L equal to 2. Because D comes from L's value 2. Here L's value 2. So here 3D means 3 plus 2 equal to 5. Clear? 4s, according to this, N equal to 4, L equal to 0. S means 0 because you know that L's value 0, 1, 2, 3, S always 0. This is the P, this is the D. That means 4s equal to 4 plus 0 to 4. So where electron will be entered first? Definitely 4s. Definitely in 4s electron will be entered first, then 3D. Though this is the, because 5 is bigger than 4, so 4s, this is the fourth shell, this is the third shell, but electron will be entered in 4s first. Clear? According to the 3D and 4p, here N equal to 3, L equal to 3, L equal to D means 1. So 3D means koto? So 3D value N equal to 3, L equal to 1. 3D means 3 plus 1 equal to 4. 3D. Sorry, L equal to here 2. 5. 4p, N equal to 4, L equal to 1. That means 4p equal to 4 plus 1 equal to 5. So here 3D equal to 4p. So where electron will be enter first, in the 3D or 4p? Where electron will be enter first, 3D or 4p? You have to understand that this one, this one. Clear? This one. That means 3D means 1, 2, 3. Here. This is the 4. So electron will enter from here, 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 then here. That means if you have the same value of different subshell, then your decision will be the which shell is the first. You have to follow the shell number. You have to follow the shell number. So firstly, if you, this is the 4p. Yeah, this, that means electron will be entered 3D, then 4p, because though both subshell has the same value, that means same energy. This is the Abba's rules, the Abba's principles. This is the Abba's principle. So clear? 3D 4s, which is the bigger than this is the bigger. 3D 4p, which are the bigger, both are same, but electron will be entered here first, then this is the low energy, this is the high energy. It is because due to the shell. So n plus L, from the value n plus L, you can easily understand. You can take the decision where electron will be the field of first. Okay. Okay, one of the main important things I am going to tell, you know that SPDF, clear? SPDF, electron generally enter according to the sequence SPDF during the configuration of the electron of an atom. So, for example, P, B. This is the lead. Lead has 82 electrons. That means it has 82 atomic numbers. You have to do configuration of the electron of lead. How will you do? This is the very big. This is the 82 electron. Okay, sodium. Sodium has the 11 electron. You can easily configure. You can do configuration very easily because this is the 11. On the other hand, chlorine. Chlorine is the 17. You can do configuration very easily. Okay, let's start. Firstly, please give the concentration on my word what I am going to tell. Firstly, you tell SSP, then take breath, then SSP, then take breath, then SPDF, then take breath, SPDF, then SPDF. Okay, start. First breath SSP. Another is the SPS. SSP, SPS. I told you, you utter SPS, then take breath, then SPS takes breath, then DPS. Then take again breath, then DPS. Then takes again breath, FDPS. FDPS. Clear? This is the one kind of trick to memorize the orbitals sequence according to the energy level. Okay, first SSP, take breath, SSP, take breath, DPS, take breath, FDPS, take breath, FDPS, take breath. If you want, then again FDPS. FDPS. Okay, every S should be start from 1. Okay, give them 1, 2, 3, 4, 5, 6, 7. Then S start 1, P start 2, D start 3, F start 4. Clear? So you have the P next. P start 2, 2, 3, 4, 5, 6. There is no another P. Then you have the D. To the D start 3, 3, 4, 5. F start 4. Only 4 is here and 5. Yeah. This is the tricky system to memorize the different subshells or different orbitals sequence of energy. Clear? Then you have the system, and you know that S is the 2 electron maximum can be occupied, P is the 6, D is the 10, F is the 14, you know earlier. So now you can easily distribute of electron in this way. PB 82 electron you have to configure here. Okay, start. You know S is the 2, 10, 12, 18, 20, 30, 36, 38, 48, 48, 54, 48, 54, 56, 56 or 14, 68, you can 10, 68 plus 10, 78. You have remaining only 4. Here you can 4. Clear? Okay. 4 electrons, 10, 12, 18, 20, 30, 38, 48, 54, 56, 56, 56, 68, 78, 82. Clear? That means this is the electron configuration. This is the electron configuration of the lead. If you know this system, whatever configuration of a atom you can do. Lanthanum may be 57. Francium 87. Francium 87 electron. Francium 87 electron you can easily distribute, and you can easily configuration of the electron of francium according to this. Okay, this is the very big. Clear? Sodium 11. Sodium 11 is the electron. So how will you configure? 11. That means you know as SSP, SPS. 1, 2, 3, 2, 3. This you have to distribute 11 electron here. 2, 2, 6. Then you have remaining 10. You got this. This is the easy. Clear? Okay. Cl 17. Chlorine has the 17 electron. How will you distribute? How will you do configuration of the electron of the chlorine? Start SPS, SPS, SSP, SPS. Okay. As it is the small number of molecules, so there will not be no need to have more SSP, SPS, SPS, DPS, DPS, FDPS, FDPS. No need. S1, 2, 3, 4, 2, 3. You have 17, 10 electron. You have 12. You have remaining 12, 5. So no need here. Clear? This is the very easy system. So firstly you have to memorize my tricky system. SSP, SPS, DPS, DPS, FDPS, FDPS. FDS should be start from 1, P should be start from 2, D should be start from 3, F should be start from 4. Molecule who is the very large like lead, radium, lanthanum, actinium. The electron xenon, the electron configuration of that atom, you need all. You need maximum. But in the exam, In the exam, the configuration of the electron generally gives us less, not higher. Okay, thank you friends. Today I will not extend my lectures more. So if you have any comments in my channels, about my lectures, please do comments without any hesitation. I will do rectify. Because I am the human, I may have some problem. So please do subscribe if you don't yet subscribe. Thanks very much.